Okay, guys. What if we kick a? What if we're trying to kick a ball at an angle instead of doing horizontal projectile motion? What do we do if, say, we're looking at a punter kicking a ball at 5 meters per second at an angle of 37 degrees above the ground? Um, what what would we need to do in order to figure out the uh, what would we need to do in order to figure out the vertical displacement? The vertical displacement, how far, if you see the word vertical displacement, what does that mean? Well, it means how high up did it go. So vertical displacement would be your distance in the y. Okay, so if you see this term, vertical displacement, it means distance in the y. So here's our situation, 5 meters per second at 37 degrees. Well, what do we do in this situation? Well, first of all, we need to recognize that 5 meters per second is not the velocity in the x, nor the velocity in the y. So what we need to do is break this up into components like we did with vectors. So we have to do Vx is equal to 5 cosine 37, and Vy is equal to 5 sine 37. Well, Vx is equal to the Vx, if you solve for it, 5 cosine 37 will be 4 meters per second, and in the y direction it will be 3 meters per second. So that gives us two numbers to work with. So we know the velocity in the y and the velocity of the x. If we're trying to figure out the vertical displacement, well, we know we're looking for dy. Okay, if this is all we're looking for in this plot, we don't have to worry about even worrying with Vx, because if you'll remember, Vy is the only thing that that's involved in the distance in the y. We don't interact with the x, so we can just forget about the x and worry about this velocity in the y. Okay, so if we look at our formula for distance in the y, distance in the y is equal to 1/2 ay t squared plus viyt. Well, we know what ay is. Ay is negative 10, so we know that dy should equal 1/2 times negative 10, okay, times some t plus an initial velocity in the y. Now, what would be the initial velocity in the y for this problem? Well, that's a little tricky because normally, whenever we had horizontal motion, the Viy was 0. But if you look here, there is a velocity in the x, and there is a velocity in the y. And that's what we calculated over here. So the initial velocity in the y, I've been writing this as Viy, so I'll rewrite this. The initial velocity in the y, Viy, is equal to 3 meters per second. So if we come over here, we'd have to do 3, sorry, keep the same color. We'd have to do 3 times t. Now, the question arises, how do we calculate this time? Well, go back to your formulas. Do we have, if we were trying to use the Vx formula, we would have to have a distance in the x to find time. Well, do we have a distance in the x? No, not really. So if we're trying to use distance in the y, we can't use this one because we're missing the distance in the y. We don't have it. So what we have to do then is use the acceleration in the y equals Vfy minus Viy divided by time. Okay? Now, the question arises, how do we know what the final velocity in the y is? Well, if we're trying to solve it when it gets to the top, hopefully you will remember that when it gets to the top, the velocity in the y at that top point is 0, which is extraordinarily convenient because we know that the initial velocity in the y here is 3. We would also, by the way, know that the final velocity in the y over here is equal to negative 3. Alright, so we know all of these things, but we're going to use this as the final velocity in the y and this as the initial velocity in the y because it will give us an easy way to calculate time. So, if the acceleration in the y is equal to the final velocity in the y minus the initial velocity in the y divided by time, and we solve for time, we would do negative 10 equals 0 minus 3 divided by t. Okay, and then switch the t and the 10 by multiplying the t up and then dividing by the 10, we would get negative 3 divided by 10 equals t. So we get, not negative 3, I'm sorry, positive 3. So we'd end up getting 0.3 seconds equals t. So if we wanted to know how long this ball was in the air, we would come back to this formula right here, and we would be able to plug in now our value for t. So now we know that t is equal to 0.3 seconds. So we can plug in 0.3 squared and 0.3. Okay? So if we plug all these numbers in, we should be able to get our answer. Turns out to be the distance in the y equals 0.45 meters. So this ball would have gone up a distance of 0.45 meters, and that would be the vertical displacement.